What do tardigrades, sunflower seeds, and baker's yeast all have in common? Well, for one thing, they all share a remarkably versatile and useful chemical compound that helps them survive extreme conditions. Let's talk about it. Trehalose is a disaccharide made up of two glucose rings connected together with an oxygen atom. The bond between them is really stable. It's not likely to come apart. Trehalose is also non-reducing, meaning that it doesn't donate electrons in reduction reactions. This is really helpful when you don't want it messing with your existing compounds. Together, these features make it very useful for organisms, specifically organisms like extremophiles. These are the outliers, the rebels, where a lot of organisms have very specific conditions that they like. These are the ones that find a way to survive outside of those conditions. Temperature, pH, salinity, radiation, pressure. Life finds a way. We've sent tardigrades to space. There are microorganisms that live at the bottom of the ocean and in the Yellowstone hot springs. Trehalose can help in a number of ways. For one thing, it forms hydrogen bonds, and this helps it integrate really nicely in place of and with water. It protects proteins from denaturing, which can be caused by extreme temperature or osmotic differences. It also reduces the damage to cellular function caused by ice crystals because it interrupts the formation of ice. Hot temperature, cold temperature, doesn't matter. Additionally, it slows water loss by forming a film. It's easily replaced when water becomes more available again, but in that moment, it helps those organisms survive until the conditions improve. This is one of the reasons that baker's yeast can survive for so long on your shelf and then be reactivated with water to be used in your cooking. Desert plants prepare for drying out in desert conditions with an increased production in trehalose. This is the key. There needs to be preparation for these extreme conditions. There can't be a shock. But in response to changes in temperatures, salinity, pressure, all of these pretty rough conditions, these organisms increase production to help buffer the exchange of water and support themselves until conditions improve. Things like mushrooms, spores, coniferous plant cones, the list goes on. There's use in it in the agricultural field for drought tolerance, especially with climate change. As these conditions, ideal conditions, are changing and shifting, it's more important than ever to have resistant plants. And so, by investigating its use in this field, we can hopefully support ourselves and the environment. This is all not mentioning its use in glycolipid barriers, chitin production, and as a primary sugar source for several insects. While us vertebrates have in fact lost the ability to synthesize trehalose, these plants and animals, it is a fascinating molecule that will continue to prove itself useful on these edges of survival.